In this video, we're going to look at how we prove the alternate exterior angles theorem. In this case, in this particular example, I'm only allowed to use alternate interior angles. You can do it with a lot of the other special rules we've been looking at, but we're just going to limit this example to only using alternate interior angles. So again, let's set up our game plan. We want to show that 1 and 7 are congruent because those are alternate exterior angles. This one's a little bit more challenging initially. We're only allowed to use alternate interior angles. So 1 and 7, there's not a nice connection right away. But I want you to think about what other angles in this picture seem to be the same as 1 or 7. And it looks like 3 and 5 would be a good choice, right? So we know that these two are the same. Those are alternate interior angles. That's the rule we're allowed to use. Because the lines are parallel, I know right away that 3 and 5 are the same. So how do you connect 3 and 5 to 1 and 7? And as you look at the picture a little bit, well, you can see that 1 and 3, there's a nice connection there with vertical angles. And the same thing with 5 and 7, those are vertical angles. So I'm able to write down that 1 and 3 are the same for a certain rule. I can then say that 3 and 5 are the same for a certain rule. And I can also say 5 and 7 are the same. So there's this chain reaction that you can kind of see nicely in the picture. And we have to think about what then allows us to go to cut out some of the middle steps and to say, well, I know now that 1 and 7 are the same. So start thinking about what that last rule might be. Again, let's just go through and write out our steps. First thing is write out the given. Okay, now you could write down a couple things at the same time. I'm just going to try and show the chain reaction kind of clearly. So in my picture here, one thing I notice is that angle 1 is congruent to angle 3. Oops, this should have been a 1 right there, right? Okay, so for my reason for step 2, that's vertical angles theorem. And then logically, we can say that angle 3 has to be congruent to angle 5. And that was because of alternate interior angles theorem. Okay, so now technically I'm able to make a connection that 1 and 5 have to be the same, tying steps 2 and 3 together. But I'm also going to say that angle 5 has to be congruent to angle 7, and that's another vertical angles theorem. Now, I am fine if later on, or even right now, if you were to just say this right along with step 2. So I'm just going to kind of say, like, you could have put it right up here and said, oh, I know angle 5 is congruent to angle 7 for the same reason, right? It's still using vertical angles. I'm fine if you just put all that together. For the sake of this proof, though, I'm just not going to put that up there so that we can see the chain reaction a little bit better in our work. So I can now say, well, 1 and 3 go together. 3 and 5 go together, so now I have a connection to 1 and 5. And 5 and 7 go together. So if I kind of follow this path, in the end I can say I know that 1 and 7 are the same. And when we have all of these angle relationships kind of congruent or equal to each other, the property that we use for that is the transitive property of congruence. Okay, I made this a 5-step proof, but like I said, with the red stuff that I crossed off, you could have put one of those steps together, 2 of those steps together, and it would have been a 4-step proof. Either one is valid, and I'm okay with however you do that. So this one has a little bit more going on, but again, hopefully the game plan that we're trying to talk about is making more and more sense. We'll stop there.